We got to know about the parts of the eyes, the defects of vision and their corrections in our previous videos. We also discussed how sensitive and complicated our eyes are. We have also learned how we can see distant and nearby objects. But the question is, can we see the various changes happening in the world? Or is there something that is not visible from our eyes? Some similar questions also arise in my mind when I see the rainbow. What happens suddenly after the rain that we see the rainbow? Or while looking at the open sky, the question arises in my mind why it is blue, why not green or red? So, do you want to know the answers to many such questions? Then stick with the video till the end. To find the answer to the first question, let's do this activity. To do this activity, we need a source of white light and a prism. Prism is an object made up of glass with two triangles and three importing sides. The angle between any two rectangular surfaces is called the angle of prism. In a dark room, place the prism on the base of the triangle and focus light on any of the rectangular surfaces. As soon as the light falls on the prism, on the other side we'll see a band of some colors. If you look at the band carefully, it has 7 colors in it: violet, indigo, blue, green, yellow, orange and red. These 7 colors can be remembered as vibgyor. This strip of colors is called the spectrum of light, and the splitting of the 7 colors of light is called dispersion. The prism refracts light and changes its direction. If you look carefully, then you'll find that each color makes a different angle with the prism and travels on its own path. Isaac Newton was the first person to obtain the spectrum of sunlight. He then uses the second inverted prism to obtain the single beam of white light. Newton said that the white light is made up of 7 colors. So, is the reason for the formation of rainbow is also the dispersion of white light coming from the sun? Yes, but we do not see any prism. Then how does the process takes place? After the rain, small drops of water are present in the atmosphere. Through these drops, the light gets refracted, get dispersed into 7 colors and then reflects internally and falls on our eyes, which is why we see the rainbow. It is to be kept in mind that the rainbow always forms in the opposite direction of the sun. So does the sun only produce white light, or is there anything else that we cannot see? Yes, electromagnetic waves produced by the sun ranging from radio rays to gamma rays. Every beam has its own wavelength. Some of them get stopped in the atmosphere and some reach to the earth. We can only see the spectrum of white light by our naked eyes. We'll read about these waves in detail in higher classes. These rays fall on various objects in the world. Every object has its own capacity of absorbing light. So, why do we see apples in red color? Because the apple absorbs all the colors except the red one, which gets reflected, and we see the apple as red in color. So, what is there in the sky that it seems blue? Does the sky as well absorb all the colors like an apple and reflect the sky blue color back? The answer is no. When these 7 colors enter our atmosphere, then they pass through the molecules of air and diminished particles present in the atmosphere, which are too small as the wavelength of the light. These particles scatter the blue light and make the sky appear blue in color. Now you must be thinking, if it depends on the wavelength, then why does the sky doesn't look violet, as it has the shortest wavelength? So now if sky appears blue due to the particles of the atmosphere, then why do we see the sky as red in the morning and evening? If you look at the time of morning and evening, then it can be seen that the sun is near the horizon and the light coming from the sun travels in the atmosphere for a longer time, while in the afternoon this distance decreases. Due to being in atmosphere for a longer time, blue and violet rays already get scattered and the red color reaches our eyes. These different colors are applications of Tyndall effect only. The scattering of light by colloidal particles in any medium gives rise to Tyndall effect. sunlight coming from the open corner in a dark room is an example of Tyndall effect. So today we have learned that behind every visible or invisible phenomenon, the secret of science is hidden. There is definitely a rationale behind every change happening in the world. Science says that we should question why any change is happening. We don't know that any one of you might help us understanding the world better by your invention or discovery like Newton did.